Hello everyone, this is Mr. Underkoffler, and today we're going to be looking at the guided notes called Simplifying Algebraic Expressions Using Like Terms. Now I'm going to split this up into three separate parts because this packet of guided notes is a little bit longer than the previous one. Let's start with some vocabulary. Terms are the parts of an algebraic expression that are separated by addition. Coefficient, that is the number that is multiplied to a variable. Now, we're going to look at lots of examples on this stuff, so just bear with me for now. A constant is a term without a variable. So it's basically a term that is only a number. No variable is present at all. Like terms, and this is the main idea of these guided notes. Like terms are terms that have the exact same variable, and it can be same multiple variables. And also, they have to be taken to the same exact power. Now, I'm not going to lie to you. Exponents are not going to be a big part of the pre-algebra math grade 7 version of these guided notes, but it is something you have to keep in mind. Oh, one more thing. Two terms that have no variables at all, which would be two constants, they are also considered to be like terms to each other. Okay, now that we went over that vocabulary real quick, let's use what we just learned to do some little identification here. So we got an algebraic expression, 8y minus 29 plus 5x. We're going to first of all figure out who are the actual terms, and then we'll talk about who the coefficients are and who the constants are. Well, first thing we got to remember, terms are supposed to be separated by addition. This is almost all addition, but right here we have subtraction. So pencils in your hand, we're going to make subtraction become slash slash, adding the opposite. And how many terms do we have? 1, 2, 3, boom. 3 terms, and they happen to be 8y, negative 29, I hope you're writing this down along with me as I give you these answers, and 5x. Now, coefficients. What are coefficients? They are the numbers that are multiplied to variables. So, 8y, the number that's multiplied to the y, is the 8, so 8 is a coefficient. Negative 29 doesn't even have a variable. So actually, negative 29 is a constant. 5x, well, that has a variable. So the coefficient part of it is the 5. So that is the other coefficient of that problem. Okay. Can you do the next one on your own? Don't forget to make subtraction become adding the opposite. And there's also subtraction here. Make it become adding the opposite there before you can figure out who the terms are. Hit pause real quick and do this on your own. All right, did you already do it? We have 1, 2, 3, 4 terms. And what are they? They're the 9k, negative 7v, don't lose the negative sign, 13k to the second power, and finally negative, make sure you have the negative sign here, negative 10xy. Who are the coefficients? Well, we're looking for the numbers that are multiplied to a variable. So 9 is a coefficient, negative 7 is a coefficient, 13 is multiplied to k squared, so 13 is a coefficient, and negative 10 is multiplied to xy, so negative 10 is a coefficient. You're like, well, Mr. Underkoffler, why didn't you mention constants like you did on the previous one? Because a constant is a number that does not even have a variable. On the example we have here, all 4 terms had variables, so there were no constants on this algebraic expression. Okay, let's talk about like terms. Like terms, as you read at the top of the page, are terms that have the exact same variable or possibly exact same variables. Let's use that down here. The left side are examples that are like terms. The right side are counterexamples, so these are things that are not like terms. And as we already said, if they have the exact same variable, they are like terms. But if one of them has a variable and the other one does not, then they're not like terms. If they have the same exact variables, w and y, then they're like terms. But if one of them has w and the other one only has y, well, those are not alike, so they are not like terms. Notice, being like terms has nothing to do with being positive or negative. So they don't have to both be positive. They don't have to both be negative. That has nothing to do with what we call like terms. Like terms is about having the same exact variable or variables. Oh, but by the way, they have to also be same variables that are to the same power. So r to the second and 5r to the second, they have the same variable and the same exponent. But over here, they don't. That's why they're not like terms over here. Now, you might be like, okay, I get the idea of like terms, but why in the world are like terms important? Here's why. It goes to the basic truths of adding and subtracting that you learned in elementary school. You learned apples plus apples gives you more apples. But apples plus bananas, well, those aren't alike anymore, are they? You can only add and subtract things together, including algebraic terms, together when they are alike. If they are not alike, if they are unlike each other, then you cannot add or subtract them together. This is basic truths of adding and subtracting. Same thing with fractions. You can't add fractions together until you have like denominators. So this is true across the board, ever since elementary school. With addition and subtraction, things have to be alike. So take a look at the example we have here, 5x plus 7. Are they like terms? No, they're not. 5 has an x, 7 does not. So they cannot be simplified. Fill in that blank. Cannot be simplified because they are not like terms. You cannot add them together and get 12x. No. But, and I believe I have this part on the right side of your paper if you're following along in your notes, 5m plus 7m. Oh, they are like terms because they both have the same variable. So, it can be simplified. I'll prove it to you. I'm going to use the distributive property in reverse. They both have a multiplier of m. If I pull that out as the multiplier outside of parentheses, this is the distributive property in reverse, then 5 plus 7 is 12. The m is still there, proving I was able to make it become 12m. So fill in this blank. 5m plus 7m can be simplified to 12m. Write that down in the blank. Now, I'll be honest with you. You don't have to show this step in the middle when we get to some practice problems on the next page. If you have two terms that both have the same variable, you can go ahead and add their coefficients, the 5 and the 7, and get 12. Keep the m on it, and you're good to go. You don't have to show this middle step in between the distributive property in reverse until we get to a future lesson, spoiler alert, later on in this unit, which this thing will then be called factoring. Again, I'm spoiling something that's coming up later. But for now, if you have like terms, you can just go ahead and add them together. Now, at the very bottom of the page, I want to bring back some properties that you need to know about that are going to be very helpful in some very unique problems coming up in the future. Multiplicative identity tells us anything times 1 equals itself. Now, common sense kind of also tells you that. But you can apply this to some algebra. 1x. What does that really mean? It means 1 times x. 1 times x. Well, we know anything times 1 is itself. So x times 1 is really just the same as x. Fill in the blank. N times negative 1 is kind of like multiply by 1, except it's negative. So instead of just saying n, we would say negative n. Now, what if there's a 0? The multiplicative property of 0 says anything times 0 equals 0. And it just so happens 0x means timesing, I'm highlighting the wrong thing, means timesing by 0. So x times 0 gives you 0. Now, why is this important? If you see x by itself, it's not the same as 0x. X by itself is actually the same as 1 times x. And that's going to help you on some future problems coming up on the next page. Speaking of the next page, turn to there right now. Oh, I forgot. I was going to make this a separate video. So that'll be the next video. This is the end for part 1. Thank you for watching. We'll see you next time.